Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new to my channel, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited to get into. So let's go ahead and read the prompt statement, right? So the problem is called path sum, right? So it says given the root of a binary tree, right, and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum, right? And it tells us also that a leaf is a node with no children, right? So that's very interesting thing that they told us that, right? A leaf node, pretty much a leaf that has no children, right? So 7 is a leaf node, 2 is a leaf node, 13 is a leaf node, and 1 is a leaf node as well, right? So now that we know that, right? So our job, right, is to find a path, right? Starting from the root, right? We always start from the root to any of the leaf nodes, right, that we just talked about, that when you add up all the values, right, leading up to the path to the leaf, right, when you add them all together, that their sum, right, equals the target sum that they're asking for, right? So we're going to be given this target sum, right, and our job is to find a path, right, that equals that target sum. So right now, a good way to solve this problem is to try every path, right? Starting from the root to a leaf node, we check every single path. Once we get to a leaf, every time we get to a leaf node, right, we check does the current, so we're gonna have a running sum verb, right? That's gonna, every time we visit a node, right, we add the node's value to the current sum verb, right? So right now, every time we visit a node, we add ourselves to the current sum, to the running sum, right? So 5 plus 4 plus 11 plus 2, that path would equal 22. And the target sum is 22, right? That's why we end up returning true, right? So once we get to a leaf node, we check, does the running sum, right, leading up to that path, does it equal the current sum? If it is, we return true. If it's not, we return false, right? To signify that this path is not a good path, right? So sorry, we couldn't find that target sum, right? So that's how we're gonna solve it, guys. So right now the running sum, right, that we're gonna, how are we gonna do it? We're gonna do 5. So once we add 5, right, then once we visit this node, the current sum will be 5, right? Then we visit this node, we add 4 to it to account for 4, right? Since we need to pass through 4. So at 4, we visit all of 4's children, right? 4, yeah, so we add 4, so 9 plus 11 is 20. So once we're here, right, we're gonna be 20, and then we're gonna end up visiting 7 and 2, right? So by the time we get to 7, we're 20, right? And 20 plus 7, 7 is the leaf node. Then we say, all right, cool. 7 does not equal 22, so we end up returning false, right? Then we visit this path, right? But by the time when we get to 2, the running sum is 20, because we considering 11, right? It's not 27, because it's 20, because at this level it's 20, right? So this is the 20 level, right? And then now 20 plus 2 equals 22, so we end up returning true, right? And then we also would visit the right, return true, and then we end up saying that answer up to the caller once we get up the recursive calls, right? So we would also visit the right, because we always visit our left and the right, and then we return either our left or the right, whichever one's true, right? So we just want any of the path, right? So 5, right? 5, we will also check the right. 5 plus 8, 13. 13 plus 13 is 26, right? 26 does not equal 22. So we return false, right? Then we keep doing this, right? At this level, guys, 5 plus 8, the running sum's 13, right? I'm saying it's not 26, it's 13. I just want to show you. So at this level, so once we get to that level, that's why we add 13, right? But we're 13 here, so we do 13 plus 4, right? At this level, right? Once we add 4, the current sum will be 17, right? 13 plus 4, and then we add plus 1 to account for that, right? So plus 4 to account for that, right? So 13 plus 4, right? 17 plus 1 is 18, does not equal, so we return false. But we already got a path that was true coming from the left side, so we're good. So that's why we end up returning true, right? For this particular example, that's not the case, right? Because we're giving this target 5, right? And from root to leaf, right? 1 plus 2, right? At this, when we get here, right, the current sum is 1, and then plus 2 gives you a 3. And to leaf node, and then we check, does it equal to this 3 equals 5, right? Nope. Then we go back up to that level, right? Then we check our right child, right? We do 1 plus 3 is 4, does not equal 5. So we send false to tell them, hey, there's no path that exists in that tree, or there's no root to leaf path that equals the target sum that you're looking for. So that's kind of how the algorithm is going to work, guys. So let's go ahead and implement that. Hopefully, when I went through the examples, it was pretty clear, right? So right now, it's going to be a depth first search, all right? So we're going to use the helper function, right? We're going to use the helper function because we want to stay consistent, guys, because we always use the helper function when we start doing the DFS, right? And my other problems. So right now, right, we're going to pass in the root. We're going to also pass in the running sum, right? The running sum will first start at 0, right? And then now we're going to have the target sum, right? So now we're going to end up crafting our helper function, right? So now we're sitting pretty good. So we do a tree node. So root, right? That's the root. And then we're also going to pass in the current sum, right? To help us accumulate the running sum, right? As we visit the nodes, guys. I'm saying? And we got the target, right? Target sum, right? So now we have our base case, right? So if root is null, right? We return false, right? If the root is null, then yeah, it's gonna be false. So that's why we have that base case, right? So now every time we visit a node, right, we add ourselves, we add the node's value, right, to the current sum, right? And then after we do that, guys, we check, is that node a leaf node, right? We check by by looking if root that left is null and root that right is null, right? So we check is the left child null? Okay, cool. Is the right child null? Cool. If they're both null, then we know for certainty that's a leaf node, right? So now, guys, the next thing that we're gonna do, once we know that it's a leaf node, right, we're gonna do a check, right? The check is gonna be, all right, cool. Is that the current sum, right? The cumulative sum that current sum variable, right? Does it equal to the target sum that we're looking for, right? If it is, then we know that's a good path. So we're gonna return true, right? That's a good path, right? If it's not, guys, if it's false, then we're gonna end up returning false to signify that's the bad path. So I'm saying that path from root to leaf does not equal to the target sum that you're looking for, guys. You know what I'm saying? And once all right, if it's not a leaf node, right, what do we do? All right, so we recursively check on left and right child, right? So we pass it with that left, right? We pass it on left child. We also pass in our current sum variable that we have, right? Also pass in our target sum, right? We do the same thing for the right. Yeah, we do the same thing for right, guys. Once we after we do that, guys, the next thing that we're gonna do, right? So we're gonna get answers from both our left and our right, right child, right? So now, what we have to do, guys, I'm saying, we have to return the left or the right, right? So we do left or right. So if either one is true, right? If there was a path that was good from my left side, then the left is gonna return true. If it's from my right side, then the right side, they will return true as well. If they're both false, right? If I didn't find anywhere in the tree, right? So it would be like 5, we check. So this path that equal false, right? One checks the left return false, right return false, then no, we return false because there's no path, right? This one would return true because the left will be true, but the right will be false, right? So it's left or right, so we go with the left, right? Left is true, so we return true. So if either one of them is true, then the answer is gonna be true, guys. You know what I'm saying? So yeah, guys, now let's check our code, right? Let's see if we pass that small test case. All right, cool. We passed that small test case. Let's check if we pass all the test cases, guys. You know what I'm saying? Awesome. We were able to pass all the test cases, guys. No, I want to thank you guys for taking the time to watch this video. And if you guys liked it, if you guys found value, make sure to like this video. And if you guys are new here, make sure to subscribe, because I'm going to do a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.